This is what your AI agent reads before it does anything. Every tool, every schema loaded into its brain upfront, whether it uses it or needs it or not. What if there is another way? So if we will go here, of course you have seen the GitHub's command list from the GitHub's MCP default set of operations. Right side, CLI output. Of course, we can type it down, open the list of core commands, actions, additional commands, and stuff. Other way, similar output, as soon as you can understand both. And of course, you are a power user, right? You know how to open the command line, how to run the tool, the CLI, how to install it, and so on. And CLI versus MCP became a battle itself. Every product is picking one right now, sometimes both, and most teams treat it as the same checkbox. Good, bad, not for me to answer. And it's not the same checkbox from many cases. And picking wrong costs product, costs you your context window, or your reliability, or every user who isn't sitting in front of the terminal, basically. So which for most products is all of them, because not every user is in front of the terminal yet. So one sentence today in this episode that reframes the debate: one concept, every hot take skips, and real production numbers, with 4 questions to be answered at the end of the day, and that will help you pick interface for you. Let's go. Here is the one sentence I've mentioned that is worth writing down. A CLI is a human-first interface that agents happen to be very good at using. MCP, on the other hand, is an agent-first interface that humans never see. Everything you just watched in the opening of the video, and every trade-off in this video basically, falls out of that sentence. But to see why, you need to, at least one concept, almost every CLI versus MCP take skips. Skipping it is why those takes go in circles. The missing concept is the host. For IT people, programmers, it might be quite familiar name and concept itself. Let me describe it a little bit for those who might not understand the host purpose of those comparisons today. A language model can't do anything, unfortunately, or yet at least. It produces text. It can write, I want to list pull requests, but something has to actually run that and hand the results back. That something is the host, the app that agent lives inside. Good example is Cloud Code, for example, used by many of you probably. Cloud Code is a host. Cloud Desktop is a host. A web chat in the browser is also a host. Your product's built-in assistant is as a host as well. The model itself is the brain. The host is the body. The hands, the terminal access, the network connection. A brain with no hands can play all day and touch nothing. The host decides which hands the agent gets. That's an often question, and of course the argument in the debates of MCP versus CLI. And yes, it can. When it's host hands, it shell. So in Cloud Call or CI pipeline, there is a shell, so the agents run CLIs all day. In a web chat or mobile app, no shell was ever exposed, so the CLI isn't worse there. It's unreachable, no matter how smart the model is. And of course, Claude and Anthropic are coming back with tools like Dispatch, which is currently in beta. So we can, open the Dispatch on the mobile application and Dispatch delegate the tasks to the Claude desktop instance, which has the wider access to the tools, which are also including the CLI tools and the bash commands as well. I want to create a controlled experiment and generally walked you through the GitHub example, which is, in my opinion, still the best one for us to explore today. But there's many others examples which are probably also good to use. The real question then is not which is better. It's what does the host expose? Hold that, because it decides everything in the second half of this video. To compare those interfaces fairly and directly, we need an example product that is shipping both. And GitHub is still probably the best example to show it for you. And you can see on the left side the MCP server listing the raw JSON output of the available commands. And on the right hand side, we have a CLI list of commands that are available for the GH CLI command. It has the same backend because the GitHub's code is using the same the REST API underneath, but we see two front doors, two interfaces. So any differences, literally, we can see through those interfaces eyes, and not by the interfaces eyes, by the tool consuming the interfaces. Not the product itself, because the product behind the scenes, which is GitHub in this example, is exactly the same. Let's talk about discovery now, because this is the fairly familiar concept from the web development for many. We talk about lazy discovery versus eager discovery. And the wall of schemas that you have seen on the JSON side of the output, that's the eager discovery. On Connect, an MCP server pushes its tool definitions into the model's context before the agent does anything. There are various models, there are various approaches. Some of them are loading all of the tools, definitions, and methods. Some of them are more modern and more optimized to selectively load the tools. And as of recording, one busy server can be even thousands of context used as a tokens, basically, just to navigate a menu or of options to be then selected from. Connect several tools like this, and you've torched a real slice of the context window on capabilities the agent may never touch or may never need. The CLI's help on the other side is quite lazy discovery. It's free until asked. We need to tell the tool, we need to tell the CLI, do this, do that, or give me this, or give me that. And a good model already knows common CLIs from training, so it often never asks us for confirmation what method or what CLI command we want to execute. Sometimes, if you will be lazy as well and you will bypass the auto model's actions, you might have seen that the tool is asking us, do we want to run this? Do we want to run that? Can you execute this Python script, for example, for us and perform this and that operation? That's more lazy kind of late in the pipeline discovery and execution of the code itself. This is the entire just give the agent a CLI argument, because as far as good it goes, it is correct. Context is the scariest resource in the agent system. And eager discovery is some kind of our tax to be paid. The numbers will improve, the principle won't. The ecosystem answer to that tax is coming with a number that genuinely surprised me. When we are playing around with what we have in MCP versus what we have in the CLIs, we can use tools like MCP Inspector. Manufact and mcp-use has their own inspector as well. There are plenty of other ones as well to explore. I prefer Manufact's one because it has a little bit better UI for my understanding. And yeah, I'm connected here to the MCP server on the GitHub. And for example, let's use one method from the MCP that will help us to get the commits. I already found it here. So I want to list the commits from one of my public open source repositories called Cebula. So you can see here even in the tool itself, but imagine that you don't have this information about the mandatory fields or optional fields. But if I will, for example, call the MCP to list commits by the owner, try to execute it, no, I have the missing parameter, repository is a missing parameter, so it will be Cebula. Yeah, execute, cool. I have the response from my MCP server, from the GitHub's MCP server, with the list of commits here. It reminds a little bit of object-oriented programming when we call the method with a set of parameters here, right? And obviously, the tool, the host itself doesn't need to know each order, for example, of parameters and its ability to be mandatory or not. LLM tools and the host itself are translating the requests, the text or the audio or whatever else input you put to the tool itself into the calls to the MCP underlying in the underlying layer. But still, it is faulty and it can have some kind of issues here as well. Same can be tested on the standard MCP inspector. As I've mentioned, it's prefer of choice on which tool and how you would like to use it. So this is how you can play around with it on the MCP level. But if I would like to play around with the CLI, on the other hand, let me do that as well for you. So if we'll go to the same repository, one thing here is that the best is to be inside of the repository itself, and then we can have a call to GitHub a CLI. And again, here, fun fact, when I was preparing for this episode was that CLI doesn't have the exact method to get the information about the list of commits. It has a method for listing PRs and so on, but this repository doesn't have too many pull requests because it was my vibe coded session. So yeah, there is a commit called GitHub search for the commits, and there is a mandatory information needed about the author of the commits, and boom, voila, I have the response from the CLI tool as well. So the same results, different ways towards the execution and towards the result itself. So the real question isn't which one makes mistakes, because both can make mistakes, both leads to the mistakes. But the question is which tells you mistake on step 1 and which one tells you at step 4. It took me a little while to, first of all, find the CLI method on GitHub's clients to list out the commits. It was back and forth to find out which parameters are needed, optional, and at this case, for example, I might not need to point myself as an author of the commits to get it, but I need multiple calls already to get the information that I might be looking for, because what if I want to have all the commits as same as I get it back from the MCP server? So yeah, I think that CLI offers some, but MCPs offers different capabilities, and most CLIs don't offers, for example, the capability of listing and presenting the results in various ways, while in the MCP we can play around with UI even though, or include the libraries to generate a nice human friendly still output of the information retrieved from the MCP. And this is, at least, with my opinion and with my eyes, more like a production grade kind of output, and more like still human friendly result that you might be looking for. But as usually, and same here, it all depends from the needs and from the use cases. Where CLIs are really more powerful and sometimes more optimized to handle the requests is generally around the composed and composability of the calls itself. Let's take this example, which still operates on the GitHub CLI and gets the Cebula's repository commits, which are authored by me, and filters them by the commits message, where the fix is present in the commit message. So that's not a simple and let's say trivial call to the API, but here we can generally get the idea of CLI power that MCP might not give us immediately, because here if you see the execution, it has both call to the API to the exact endpoint. I here shorten the path to also get the correct results. Then it is a formatted set of the results retrieved back, and at the same time additional filter, extract, and limitation. Even though because I didn't want to get all of them. For example, I wanted to get just the specific number. All of that is outside of model. So again, no costs attached, no weird back and forth, and they are here directly for me, accessible for whatever I want to do. So yeah, classic MCP composition is not that straightforward, because MCP needs to go through the model, needs to call load results from the best matching method into the context, then think again and call again. So every step is some kind of a round trip, and every intermediate payload transits the context window, even if you needed one call in that particular manner. And again, when there is a need, there is a way. So we also observed some kind of evolution on that problems, because sometimes it's missed, but the consistent answer to this problem, this particular problem of multiple calls going back and forth, is some kind of optimization where agents are writing code that calls the MCP tools programmatically. So agent can instruct the model to write some kind of script that will do, for example, similar thing that I just did on the API CLI call. And that's an awesome solution, which was also mentioned by Cloudflare on their publication, which was shared in February this year. They called it a code mode, where they mentioned about how they are giving the powers to the model to do exactly what I've just mentioned. So write code against a specific SDK or the CLI or whatever else, and then execute it directly. And if you'll take a look on here, they compared the approach, of course, with their volume of the traffic, and they've observed a lot of the optimized results. So if you can take a look here, a raw OpenAPI spec in prompt was almost a 2 million token costs with a huge context used to execute that. The native MCP approach with the full schemas loaded took 1,170,000 tokens. And the native MCP, which required just parameters, was already having a significant reduction of the token cost, and 244,000 of tokens were used. When code mode, that's impressive. It loaded just 2 tools, right? So previously almost 2,500 plus tools, only 2 tools, and only 1,000-ish tokens consumed. And imagine that this call or this method, this operation is executed heavily. So still knowing or letting the model know what to use behind the scenes, translated into the specific executions, might be in some cases the hidden superpower that will save a lot of bandwidth and a lot of tokens generally when it comes to that. So and it's not only Cloudflare's trick, right? So it's not only Cloudflare who did that or does that on a daily basis. Many platforms are either blocking their whole API platform and collapsed it into 3 calls, or are exposing tools which has 3 different entries into their platforms. Those entries are usually the discover tool, or the plan tool, and the execute tool. So despite of the needs and the execution plans, tools are using one or another, and not trying to go back and forth and switch the tools when they're operating on that. So instead of let's say 300 item menu or list of tools that are available, they are listing 3 in that case, and that's quite easier even to understand when it's not only to be understood by the agents. Cloudflare's approach basically hidden a couple of the calls behind some others methods. Literally, in their example, there was a search method and the execute method, which roughly is 1,000 tokens. So 99.9% of reduction just to, again, get and find the information first before it will be processed. So yeah, it is this kind of, again, lazy versus eager approach to discovery. And inside of the MCPs, we can be the ones who are controlling what is happening and when. Because, you know, in both of those cases, code is calling the type tools in the CLI pipeline. Yeah, despite of the fact if it's from the CLI or the MCP, contracts. Discovery plan executes this kind of lazy discovery, and then MCP transports that. Basically, the two philosophies here are not competing with each other. It's they're absorbing each other partially based on the best ideas that they can offer for the final consumption. Let me show you an example that I've built for showing you how the MCP can handle the stuff. I used the MCP client here from the mcp-use library, which has an amazing set of framework-like approaches to working with the MCPs in general. I love it, and because I was not having enough information to, you know, go deep inside of the MCP formulas, and there was no default setups like this inside of the cloud or other tools which I've used when I started. It gave me a huge shortcut to accomplish what I really wanted to accomplish. And this example is extremely simple, right? We have some kind of basic input information. We construct the client with the basic authentication, create a session, and we call the method, we call the tool, and imagine this as your kind of MCP layer. You can you know, write the code, you can generate the code, you can do multiple operations here and orchestrate them how you want it to get orchestrated before even it gets orchestrated by the model or by the agent inside of the session. So it's quite useful, and here if I will show you how it is executed, this demo tool itself, it's extremely nice. Because you know, we will get the same results, but with the more tailored, more controlled approach here. So I'm calling the demo TypeScript file, and if you remember the session which we had in the previous exploration, it was the exact same 5 commits that I wanted to retrieve. I do hope that you see some kind of superpowers of both approaches, and you might want to know now and understand when and which approach is better. Generally, where I've benefited from using MCP is where I have a control over what is happening. Inside of my example, which I will show you in a bit, or I will describe in a bit, I had some kind of conditional checks. I had some feature flags inside of the code which were deciding if the execution of this particular tool or even method inside of the tool should be executed in the first place, should be allowed to be executed. Do we want to connect to the LLM or to the external model in general, or should we not do it? Also, the other part which is not given to us by the CLIs is the observability part, because in MCP, in the code, as you can see, as in any kind of other code, we can put some extensive logging, extensive information exposure, so we will know what is happening and what people are doing, what people are using. mcp-use and Manufacture in general also has this platform where you can do do that inside of the cloud website friendly interface. So it's extremely handy and useful to know what is happening inside of your applications. And here, you can build your own method chains, you can build your own levels of abstractions, entry points, the interfaces that you are controlling, and still keep them separate for the separate purposes. And until at least all of your users or most of your users will be command line tools, you might want to have both still. And again, nothing stops you from writing one amazing implementation layer and multiple interfaces that then consumes or implements the interface that you were just exposing. Okay, let's try to conclude a little and go towards some kind of conclusion and summary. We will go through those questions that I've mentioned to you earlier that will help you and us generally to decide which way to go when it comes to building tools like MCPs or CLIs. So the first question is your user a terminal? That might be a stupid question, but it's not stupid because you remember the host. A CLI requires the host to expose a shell, a local install, a file system, and it's completely fine for cloud code and CI. Absurd and stupid, definitely for a web chat or a mobile app or the assistant embedded in your SaaS product, for example. MCP requires a client and the connection, and that's the whole list. If you take a look on the industry and generally tools, what they are shipping and what they are doing currently, so you will see platforms like Slack, Notion, Linear, Jira, Salesforce, and many others like that, which are directly saying that there is no CLI needs generally because their users are mostly living outside of the terminals, and they are not yet asking for it briefly or on demand. On the second hand, you might have see tools like GitHub, Stripe, Cloudflare, Supabase, Vercel, and many others which are heavy in tech. They have power users like me and you probably, and they ships both because they know that it all depends in our industry, and some might need a CLI direct call, some might need an MCP consumption. So it really depends here from the real needs and from the real understanding of the final users. So if your users are more like dev heavy, then you definitely need to ship both, or at least start from the ones that are mostly needed at the moment. Here's the small proof that host concept isn't just my mental model, because the industry is already building infrastructure around it. So there's a second twist. Hosts don't just differ in whether they expose your server. They differ in how they run it. The same MCP server can pass in one client and silently break in another over something as small as a missing output schema. So different hosts, different capabilities, and different quirks. And it sounds familiar probably for many of you, because hosts in this kind of approach might be seen as new browsers. And I've seen a couple of the tweets recently about that who will use browser in couple of months or years, depends on the speed of the adoption of the agentic development. Same page renders differently in each one, same server behaves differently in each host. You all, maybe not all, but some of you who worked in the web industry might remember the Internet Explorer dramas, now Safari dramas, and all the other stuff. So it all depends from how we will prepare the output to be presented. And standards like MCP as a protocol are making sure that it will be maintained despite of the fact how it will be then presented in the output. And you might want to combine those outputs, combine those information, and present them as you wish, because you are not obligated to present it in the specific way to satisfy the both. So that's the first question. If you will take a look on this image, you will see an approach to multi-host kind of collaboration and discipline in between of the tools. Exactly like in the browser era, a whole testing category has appeared now. And when we talk about MCPs, there is a platform called mcp-jam. For example, probably one of many that it is some kind of inspector that runs your server against the matrix of clients and tells you where it breaks inspectors, client matrices, evals, are gating merges in CI, and so on and so on. So if you're building the MCP, you also want to test it against the platforms. I saw recently the demo of MCP Jam, and I kind of like this as well. Same as from the same as Manufact team, they are delivering an amazing overview of what MCPs can do and where they can run and how they will be consumed. So when interface grows, its own testing discipline grows with it, and it's no longer just a checkbox to have. It's a full, almost a platform, to maintain. And obviously, if it will be growing, the whole maintenance cost will be also growing with it. And it's not just a method, or it's not just an API. It's something what is used by clients, and even if clients are agents, they are still clients, right? So you want to satisfy them, you want to deliver the quality output, you want to be performant, you don't want to let them wait for too long. And yeah, if we'll take a look on some still again industry examples, one of the amazing ones is recent, the email platform. They shipped the entire ladder, a CLI for the terminal, an open source local MCP server for all of the desktop clients, and then a hosted remote MCP server with the full Auth for everything else. Their stated reasoning is exactly same as my thesis here, like agents live everywhere now. Your terminal, your browser, your automation tools. So the interface has to exist everywhere agents lives. One product, their interfaces, one principle, meet the agents where its host is. That's how I would like to summarize that, because that's why the whole CLI or MCP idea collapses. For most products, into MCP first, and maybe also a CLI for your developers segment. And one of the final sections that I wanted to mention during this episode in this video is about authentication and general identity versus scoped grants that might be given to tools. Stripe is a good example to use as the one here, because they makes it all vivid, and because it ships both interfaces, and it's all about money as well. I think it's something what we can use as some kind of example in the market platform standard now. The Stripe CLI runs with our local credentials. Everything that they can do, agent can also do as well. So if you are a solo developer and you might want to have a loop, you might have some kind of loop for yourself, and that's fine probably. When you want to embed that agent into a product, which is acting for hundreds or thousands of users, then the agent inherits the whole identity, and the agent becomes the incident report waiting for a timestamp. MCP's model builds on OAuth, which is like another standard which is commonly set inside of the industry these days. It has the per user concept, scoped tokens, revoke one user without touching the rest. That's the basic concept of it. And the host that mediates, with tools, and which tools are even exposed, decides what can be retrieved and how. Even when a host could grant a full shell, it usually shouldn't. And if we want to be in control of what agents are doing and what they are calling, obviously we need to spend some time tailoring the scopes and the accesses layers and levels, which will be granting for the tokens, access tokens for our tools and for the servers. What might be still kind of uncomfortable part here is like MCP is still young. The security around it is growing with it at the same time. It has some bottlenecks, it has some issues, but what it doesn't. I think the only difference when it comes to the security, authentication, and access levels here, it's like you need to put credentials somewhere for the MCP. You can have it, you know, inside of the secrets. You can have them inside of the hosts, the paths inside of your local ecosystem. If you are calling MCPs from the locals, if you are using some MCP servers through the web, you might want to use platforms which are offering the secret access or secrets hosting for the MCPs to take this pain from your head and to let you just expose the right information for the right tools. And yeah, obviously the CLIs in this case are your home, and until you are not using any tools which should have access to too much on your computer, then you should feel more safe when it comes to the access levels that are given to the CLIs rather than to the MCPs. But after a while, since I started playing with both, I don't feel scared anymore about MCP security. It's more about, again, architecture decisions on how to store it, where to store it, and how, and if we are secure enough to deliver it to the public access. And the final story, personal story from me about the case where only MCP was the answer. It's a story from my own build, and let me bring it to you before we'll disappear from here. I've been building something what I called an upgrade advisor for a CMS platform at the beginning, because I used to work for the CMS based solutions for too many years recently. In the plain terms, I wanted an AI that checks its migration capabilities and gives me the advices based on the analysis of the code, analysis of the common cases and instructions that I was collecting for years when I was doing this myself before agents took over. And instead of guessing it from project documentation, if it ever exists, or you know, relying on the human code review or even static code analysis that we were doing for the projects, I wanted a set of checks, almost like a health checks of the specific areas of the project, and then report that I will then use to recommend the best approach to be taken over with this particular project. So the tool was supposed to analyze the code base and then validates everything, every finding against a clean running instance of the target version, and yeah, ask if does it behave the way as the new version. Of course, do not guess, don't make mistakes. All those prompts were used when I was building the tool. And here, yeah, there's no CLI. There's no CLI platform that will interrogate a running system's real behavior. Obviously, we can aim to combine, you know, Playwright and or similar platforms to do the real users end-to-end tests and perform those actions, but it will be like a problematic and also long process running tool that will give me the answers that I might collate myself or collate with a tool based on some kind of analysis. So the architecture that I came up with here was about having MCP servers doing the targeted jobs, targeted services for me and for my particular analysis now. One is for the legacy artifacts, one for the breaking changes and from the documentation itself, and one is the live instance, which is orchestrating the programmatic encode with the mcp-use. Same library from the demo earlier, which I showed you, same pattern as the Cloudflare numbers, but real build and real life examples. I also used some kind of feature flags gated approach, as I've mentioned to you when I was talking about the demo, because I wanted to control who has access to what on the runtime level. So that's the story, and here it did an amazing job, because I was able to run it against a couple of the projects, get the output as I wanted, and it confirmed my overview and my understanding of the project with even more information, and of course it was almost immediate. So I didn't want to wait for the outputs, or didn't want to spend time doing this sometimes boring, sometimes not boring work. And it's time for the honest ending. The truth is that the CLI versus MCP, it was never a war, and it shouldn't be a war. And yeah, of course, wrapping your existing CLI in a thin MCP server is often exactly the right move. That's not cheating, and no one is checking what is behind the MCP, at least from what I know. The CLI stays, some kind of battle-tested engine. The implementation of the methods when we will be going from top level to low level objective approach to the execution of the platform or tool or whatever else we are building. MCP becomes this kind of typed guy, the permissionated remotable front door towards the execution of whatever else inside itself hosts has. Layers, multiple layers, not rivals instead in the understanding of the code execution. Terminal agents will still skip the server for the raw CLI because they are clever. They won't be trying to match the tool if we won't instruct them to do so. They will be clever, and even more clever, to convert or build the code that is required to call the CLI if they will decide and resonate towards this approach anyway. The more important part will be to instruct agent to do the correct choices for the cheaper interface to go with. So I see the huge opportunity right now in optimization, more like implementation part, because for me, it's not a question, should we have both? I think we should have both when it comes to the platforms which are supposed to be consumed by multiple clients, multiple hosts, as we discussed. And 4 questions that I've mentioned to you, and 4 questions that I use right now to narrow down the decision paths are the following ones. So first is like, what does the agent host expose? No shell, MCP. Conversation is over. So that's the first question in my decision chart condition-based approach. Second question is, who's the user, who's the end user? Developers might go CLI all the way, even though I was the one who always preferred the UI over CLIs, and I still do. But nobody else is that power user as developers and technical people. Even now, if we're talking about AI adoption, and if you'll talk to someone about the cloud, and they saw demos about CLIs and platforms and command line interfaces, they will be scared about talking about cloud, when in reality you have the cloud code, cloud desktop application, which is human ready enough, and they can use it. So who is your user? Is it a technical user? Maybe CLI is enough. Is it a human, not a developer? Maybe MCP is the answer, because then it will be possible to be consumed from the desktop applications without command line interfaces as well. Then the third question is, what's the reliability bar? Demos can tolerate the fuzzy text, but if you are going to the production, you want to have schemas, you want to be structured, you want to control what is happening, you want agents to control what's happening. So if you set this bar high, probably you will get easier answer. If you will have a low entry bar for that, you will tolerate more fuzziness. If you are on the MVP of MVP's level, awesome. Don't go beyond the level that you need at the same at the time. And last but not least question is like, what's the trust model? So if you want to be isolated from servers, from hostings, from platforms, and you want to control the whole identity locally, you have the answer already. If you would like to be scoped, consent and revocable, you want to maybe build a platform which controls the identity access to the tools behind it, that would help you to decide which way to take, and if include both from the very beginning, or maybe not. And most products, as I've mentioned earlier, land on MCP first, CLI for the dev segment later, or at the same time, because as it was previously, it was like, API first approach to some kind of software development. Then the web applications were the first clients of the APIs. That's how a lot of software was born. Now I feel like, at least my approach right now to developing things is like, I start from the MCP first approach. So I think about agents calling my tool to get something out of it. So more like a behavior-driven development, but MCP-driven development. So what is the use case that agent might want from my tool, my platform? And then behind the scenes, it might be one, multiple, many non-CLI calls to the APIs and multiple other tools inside of the execution path. So now I hope that you know why they are doing that, why we are doing that layer by layer, and what reasoning holds long after the quarters token numbers are ancient history in that case, right? So yeah, I hope that I will share the full written deep dive with you at some point as well. It took me a little to record this video. I was going back and forth, so I do hope that I was able to edit it in the way that I will be happy to share it with you. And yeah, you know where to find me. If you have some cool examples, if you have built something what is either CLI, MCP, or both, please, you know what to do. Drop down the information about your product, your struggles or successes. And yeah, we'll see each other on the next one. Thank you for watching, and do all the crazy YouTuber stuff to help me promote it amongst the fellow busy programmers. Stay tuned. See you soon.